Question 92. If temperature decreases when flying at constant calibrated airspeed at flight level 200, Mach meter indication will dash and true Mach number will dash. So I have taken two air masses here. One in which the temperature is 30 degrees Celsius, another one in which the temperature is colder than that 20 degrees Celsius. You are flying at a constant altitude of flight level 200. You're flying in warm air mass, then you enter colder air mass. Calibrated airspeed in both air masses is 200 knots. Okay, so under this given conditions, when you calculate Mach number using CX3 or using manual calculation, what do you get? You get a Mach number of 0.44 in warm air mass, Mach number of 0.44 in cold air mass. Similarly, true airspeed of 299 knots in warm air mass and a slower airspeed of 294 knots in cold air mass. That means when you travel from warm air mass to cold air mass, the Mach meter indication will not change. Okay, it will remain the same 0.44, 0.44. And the true Mach number will also not change. It should remain the same because we have calculated it. But now here the only option that is the most appropriate is option Charlie, such as Mach meter indication won't change and the true Mach number will increase. So maybe there is a printing error. So option Charlie. Next, the correct indications when taxiing in a turn to the left. Not taxiing. Taxiing is that maneuver which can happen only on the ground. So when you taxi your aircraft on the ground to the left, the needle or this miniature aircraft will show a left turn like this. And the ball in the inclinometer will go to the right hand side. Why? Always remember, whenever you are taxiing on the ground, the turn and slip indicator will show you a skidding turn. A skidding turn. What is a skidding turn? Skidding turn means you are getting thrown outside of the turn. So let's say this is the center of the circle and you want to make a left turn like this. If your turn is not coordinated, it's uncoordinated, and it's a skidding uncoordinated flight, so you will get thrown outside of the turn like this. And the ball in the inclinometer will go to the right hand side. It indicates that. So in a skidding turn, the needle or the miniature aircraft is to the left, ball is to the right hand side, opposite directions. Now why does a skid happen? Skid happens because of two reasons. Insufficient bank angle. You want to make a left hand turn, but if you don't bank the aircraft sufficiently, then this skidding will happen. Or if you don't apply sufficient rudder pressure, then also skidding can happen. So what is the solution? If cause solution is increase your bank angle. Increase your bank angle. And the second one, step on the rudder. If the ball moves to the right, press the right rudder. If the ball moves to the left, press the left rudder. So step on the rudder. Correct? So this is the solution. Now this ball gets thrown out of the turn, away from the center of the circle, under the influence of CF. What is CF? CF is nothing but centrifugal force. Centrifugal force. That force which takes you out of the turn, away from the center. When you increase the bank angle of your aircraft as a solution to a skidding turn, what happens? Bank angle increases, aircraft will bend towards the center of the circle and there will be increase in centripetal force. This centripetal force will pull the ball inside of the turn and this ball will come towards the center. And then you kick that ball, then you maintain your bank angle rudder pressure so as to keep that ball right in the center. Now, whenever you're taxiing on the ground surface, you taxi without lifting your wings, right? If you want to turn your aircraft in the atmosphere, let's say you want to make a left turn. You will turn your aircraft, bank your aircraft to the left side. You will lift the right wing up and the left wing will go down. That's how you make a bank turn to the left. But on the ground, you don't lift your wings. Your wings are level with respect to the ground surface. All you're doing is apply the left rudder pressure if you want to go left, and your aircraft will turn its nose wheel to the left hand side and it will make a left turn. So, but the turn and slip indicator does not know the difference between your aircraft turning on the ground or making a turn in the air. Okay, so it will only tell you about slipping, skidding, coordinated flight. So since it does not know that aircraft is on the ground, so it will not give you the right indication. It will give you a skidding turn indication, because your turn and slip indicator thinks that your aircraft is not banking, or you have not banked your aircraft sufficiently to make a left turn. So it shows an innocent behavior, and it shows a skidding turn. Whether you make a left turn whether you make a left turn or right turn, it will show a skidding turn. So the correct answer here is needle. Now here the needle stands for miniature aircraft. So the needle will go to the left and ball will go to the right. 94. A slip directional gyro derives its directional signal from a direct reading magnetic compass, the flight director, the flux valve. So correct answer is flux valve. 95. The gyro in a vertical reference data generator has 2 degrees of freedom and vertical axis. Bravo and Charlie are the right answer. DGI errors are caused by mechanical imperfections, yes. Earth rate, yes. Transport vendor, yes. Banking and pitching, yes. So options 1, 2, 3 and 4 are right options. An aeroplane is on an IFR flight. The flight is to be changed from IFR back to VFR. Is it possible? No, only ATC can order you to do it. No, you have to remain IFR in accordance to the filed flight plan. Yes, the pilot in command must inform ATC using the phrase cancelling my IFR flight. So option Charlie. Yes, you can cancel your IFR flight plan. You can file an IFR flight plan. You can amend it. You can cancel it. Okay, so these possibilities are available. Next. Course 085, winds 030 at 100. So you are getting a right correction left crosswind. Task is given distance, calculate through heading and flight time. To calculate flight time, we need to know distance divided by ground speed. So we know the distance, we do not know the ground speed. We can calculate that using CX3. Go to wind correction option. Now task. Task is 470. Course is 085. Winds 30100. So under the given conditions, task 470, course 853. So under the given conditions, true airspeed of 470 knots, course 085, winds 030 at 100, ground speed 440.96. So ground speed will be 441 knots and true heading will be 086. 086. Okay, there is a correction here. Wind direction is 30. Let me do this again. Wind direction is 30. Speed is 100. Course 85, 470. Yeah. Ground speed is 405 knots. Ground speed is 405. Make the correction. 405. And true heading is 075. True heading is 075. Now, flight time will be distance divided by speed. So 265 nautical mile divided by ground speed 405. So 265 divided by 405 is 39 minutes. 0 hour 39 minutes. Question 99. When climbing through an isothermal layer at constant calibrated airspeed, what will happen to your true airspeed? So I have explained this many times. Let's say this is your atmospheric layer and you want to climb in this layer at constant calibrated airspeed. At constant calibrated airspeed. So what will happen as you climb to higher altitudes? Atmospheric pressure decreases. Now your airspeed indicator is nothing but your pressure instrument. It's nothing but your pressure instrument, right? Which registers dynamic pressure, and this dynamic pressure is nothing but your indicated airspeed or calibrated airspeed, which is corrected for position error, pressure error. Now when you climb to higher and higher altitudes, what will happen? Atmospheric pressure surrounding your aircraft will decrease. If this atmospheric pressure decreases, your airspeed indicator will register less and less pressure in it. As the registration of pressure decreases, right? Registration of pressure uh, goes on decreasing as you go to higher and higher altitudes. The dynamic pressure will also reduce, and the speed as a result shown to you will also go on decreasing. You may be flying at a constant speed, but the indication given to you by the airspeed indicator will go on decreasing in value, because the airspeed indicator needs pressure to show your calibrated airspeed. If it doesn't have adequate pressure inputs, the output will also be or will also suffer. So the calibrated airspeed shown to you will decrease. Now, in order to prevent that from happening, to stop that from happening, you want to maintain that constant calibrated airspeed indication. What will you have to do? You will have to you will have to increase the true airspeed of your aircraft. This true airspeed of your aircraft dynamic pressure, will increase dynamic pressure or impact pressure around your pitot tube. This impact pressure, this additional increase in speed which creates an additional dynamic pressure, okay, this new dynamic pressure will compensate for any reduction in static pressure at, at high levels or high altitudes, right? It will compensate for that. So that's why if you want a constant calibrated airspeed climb, you will have to increase your true airspeed. Increase true airspeed. Now this constant gas climb may be maybe in an isothermal layer, inversion layer, ice atmosphere, whatever. Constant gas you want, your true airspeed must increase. Calibrated airspeed doesn't depend on temperature. It only depends on pressure. Last question. Okay, so this last question is about they will give you a picture and you have to identify whether that the mode is it VOR mode, plan mode, map mode. For that, you will have to read the FIS Electronic Flight Information Service system chapter, and you have to memorize the symbols. The best way you can do it is draw the symbols using sketch pens, color pens, so that you remember the colors, the shapes. Okay, that is the solution. So I hope you have understood all the 9 questions I've done in this video lecture. And if you have any doubts, questions, comments, let me know in the comment box of this lecture. Best of luck. In my next video lectures, I will be solving the remaining question papers, sample paper number 3, sample 4, sample 5. Watch them. I request you all to share this channel with your friends, subscribe if you haven't yet, and hit the like button if you have liked this video lecture. Thank you.